welcome to Desktop Super LADYADA.
That's right. It's a super beta. Welcome to another Desktop LADYADA.
That's right.
I don't even know if the game is still going on.
Go team.
Go team. We're going to catch up on what I've been working on this week. It's not been a heavy-duty engineering week. It took a little bit of the week a little slow, but I did some stuff. I thought I could show off some of the things that have passed by my desk. But to start, Mr. Lady, do you have any updates, things you want to tell people?
Normal show schedule this week. Only difference is Noah and Pedro will be doing the show and tell. We'll be doing Ask an Engineer at 8 p.m. Noah and Pedro are doing show and tell at 7:30.
It's been awesome.
And they also do 3D Hangouts every Wednesday. JP show is on Tuesday, product pick, live from the product pages. And then Thursday, JP's workshop. And then Friday, deep dives with Scott. And we also have a bunch of videos that we'll be posting all across social media networks and more over on TikTok, where most of 7,000 people.
I know, we got to get back on the TikToks.
Yeah, we're there. We're putting a
happening.
bunch of stuff there.
It's happening.
A lot of people want to see electronics on TikTok, and we're happy to serve those electronics up over there too. So that's pretty much the news. We're also still doing the 100 days of masking, so probably for the next 80 days-ish or so, if you order pretty much anything in the USA, we toss in a mask. Surely you have one already, so maybe give this to someone or just store it away because
it's handy. I put it in my coat pocket in case, when I'm out, somebody needs one or mine, something happens to it.
Yep.
It's good to have.
All right, LADYADA, so kick it off.
Okay, let's start it off. Okay, so the first thing on my desk. So one thing I've been... Okay, let's start with these Neopixels because let's go to my computer because I'm actually going to teach. Yeah. So I saw that you sent this to me and I saw this. So Geek Mom Projects was like... She said, I found these weird Neopixel LEDs that remember their location. They're like pre-addressed. And I was like, oh, wait, I think I have those LEDs. Like, I actually got this sample a few months ago, and I didn't realize what they were. Because when I looked at them, I thought that they were like the LEDs that we have. I'll show you. We have Neopixel 4-inch. So we have like these Neopixels, and I thought that these were the same thing, where like you see that there's one wire that's shared power, and then there's another side that's shared ground, and then this wire goes in, and then there's another wire, like it's cut and separated. There's 4 contacts, and there's a chain, one input and one output. And I actually thought that these were the same thing. I didn't realize that they were different until she mentioned it, and I was like, wait, I actually have some of these samples. And I didn't realize what she noticed, which was, hold on, back up, that they all share 3 wires. There's no input and output. So let's look at the overhead at this like funky, weird thing. So I'll just unplug this so it's not overly lit up. So this is let's super zoom in. So this is the one LED, and I tried scraping away as much as possible. I wasn't able to super scrape. It's really like plastic, epoxied. But yeah, there's this red wire, which is 5 volts power. There's the middle wire, which is ground, and then the other edge wire is data. And what's interesting is that instead of the way Neopixels normally work, where data, you send... Let's say you're lighting up 16 pixels in a ring. I'll grab a ring to... Oh, wait, I can't because it's behind the thing. If you have a ring or like a strand of 10 pixels, you send the data from... You send the data from the Arduino to like the first pixel, and the first pixel takes off 3 bytes of data and then sends the rest down to the next pixel, which takes 3 bytes of data off and sends it down until at the end... There's no more data to be shifted out because each pixel removes the first 3 bytes before echoing out the rest of the data. So it's like a shift register, like it takes data out and then bucket brigades the rest down. These don't do that. These are parallel. So what was interesting is I was able to at the end of this strand, it's just like it's very strange. At the end of the strand, I was looking with an oscilloscope at the data line, and the data line had all the data on it because obviously it's not being shifted out. It's just being totally parallel, sent to all the pixels in the strand, which was 100 pixels total. And So it's interesting is that, each one has a unique address, 1 to 100. And what it does is rather than like bucket bringing the data, it actually looks, it grabs a whole data stream and then like indexes into it, finds the data for its address, and then uses that to light up the LED. So it's still Neopixel compatible. It just doesn't act the way Neopixels normally act. So to demonstrate, I have this, I've got a strand of like 100 pieces. So, and then over here, I cut off 10 pieces. So if you look, here I'll show like this way. So this is the first pixel, like literally the first pixel. And this is the 90th pixel. And so it's interesting is that like, even though these are parallel, they don't light up at the same order because this pixel actually remembers its address. Like I cut it and I connected them both in parallel to the same pin, but they don't act in parallel. Like you see like this lights up green and then it lights green. This lights up blue and then blue, red, red. Because it actually like knows where it's supposed to be in the strand. So like really weird. I don't really exactly know what these are good for. If I had a choice of which I would rather, like if only one existed in this universe, if I had to pick like a multiverse version of Neopixels, I prefer the one we have. That said, like this could be useful for something. I mean, like one thing that is nice is that you can have multiple parallel strands and then still address them uniquely. Like you can use one pin and have multiple strands hanging off that pin, but they're uniquely identified. And this is kind of cool and weird. So, and it's got a magnet wire. You have to heat it up to be able to contact. I heated it up with a soldering iron to get rid of the covering and then solder to it. So kind of interesting, like wire wound. And then, what's nice, of course, is it's because it's protected. You can wrap it up and it still works even when all the wires are touching, because the wires are actually covered with a thin plastic or something. So this is a whole bunch of pixels. That sounds like the first thing I looked at. It's kind of weird. What do you think, Phil? Weird? Kind of weird?
Well, I think it's one of those things where the street finds a use for it. So even though we don't have an immediate what would folks use this for? I think this is going to be one of those things where we'll get some surprising examples and.
Yeah, it's definitely like unique. I mean, like it's cool. You don't have the issue where like one pixel breaks and the rest of them die. Like, that is one of the nice things. Like you don't have the one of them went bad and all the others go bad because the data is all shared. So that's one thing I looked at. So maybe I'll order some of these. That's a sample. I
think folks are also getting used to the idea of persistent memory because we do a lot of e-ink stuff.
Yeah.
So like you turn off, you're finished with this like really cool CircuitPython powered, low powered device, and the e-ink display persists. Maybe there's something to be said about strands of pixels remembering certain things.
Very cool. Okay, so next up, I'm just gonna get this focused. Great. Next up, I dealt with revisions. I really hate revisions, but they happen. Folks who know me know I do my best to avoid revisions as much as possible, but eventually I can't take it anymore, or I have no choice. So this is the.
We'll do some questions after this that just came in because there's always a delay, so we'll.
Oh yeah. Let me. This one's really easy. So this is fast. So the PA6H is the GPS, the ultimate GPS. We've had now 3 revisions. It's gone from really chonky to a nice slim GPS. I love this GPS because it's got everything. It's got built-in antenna. It's got external antenna support. It's got fixed output. It's got pulse per second output. It's configurable. It has a lot of options. Has up to 10 hertz output. It's kind of like I personally think it's one of the better GPSs. GPSs are pretty much all the same price, and given that, I really like this. And then of course in September we got notice from Sierra Wireless. You can go to the computer real fast. I'll just show this off. That it has a end of life notice, PA4H, PA6H. So the company that made these was purchased by Sierra, and then Sierra promptly killed it, which sucks. So, I've kind of known this for a year or so, or a year or two, but I've been really avoiding it. I like to wait. I know it's counterintuitive, but I actually kind of like to wait till the last minute to deal with revisions, because I've seen revisions get pulled or the timelines moved around. So it's like, it's good to know about a revision, but I always have a backup plan, but I don't actually take action until like the end. So basically, we just got like our final shipment of these PA6Hs in. You can do a lifetime buy. But it turns out that there's a alternative. So let's go to the overhead again. I can show off the alternative. So one thing that was kind of nice is, I guess some people who worked at the original company left and started a competing company. And they basically made like a drop-in replacement product, which is great. So this is the PA1616. Is it completely 100% identical? No. So far it's not. But it is 95% identical. It's the same shape and size. It's the same pinout. Same functionality. As far as I can tell, the same performance, same antenna management, same fixed, same pulse per second. The thing that's changed is the instructions, the command name for querying the antenna changed a little bit. It returns a 2 instead of a 3, like it's a CD, not a PG, whatever. It's not too bad. I mean, our library can adjust for the changes, but it's just, we'll have to document it. And the built-in locus was what it's called, data logging. I couldn't quite get it working. I don't know anyone that's actually using the locus built-in program at data logging. When this first came out, adding data logging to a microcontroller was really hard. Because we were using like at Mega 168s, and so we actually didn't have enough flash or RAM to support an SD card as well as GPS. But nowadays, it's actually, a lot of chips and boards that we have plenty of memory. You could add an SD card, and then you can data log however you like, or they even have built-in SPI flash, and you can just data log to the built-in flash. So if I do the revision, well, I have to do the revision because I don't want to discontinue the Ultimate GPS. It's going to have to kind of come with a caveat of, hey, the built-in. I'm going to keep trying to contact the company that made the version and asked, is there some way to enable the locus built-in data logging, and hopefully I can do that, and maybe change the output from the antenna command to match this one, so it's as close as possible to a drop-in replacement. But revisions are always painful. It's part of engineering. I have seen revisions not like tank a company, but really damage them. So it's something you have to keep in mind when engineering. Is you have to be ready for anything that you use, even the most popular GPS module we stock and sell, and that's clearly a lot are sold. They've decided to discontinue it. There's a replacement, but I don't think the replacement is as good. I'll carry the replacement as well that the Sierra came up with. It's good, but it's not as good, I think. I don't know. That's how it is. Nothing is quite as good as your first Cherry Coke. All right, there's a question?
Okay, yeah, let's go to the LEDs.
Yeah.
Is there a way to identify the address of an LED other than counting where you cut?
No. It's like they're just embedded in epoxy.
Next up, do you send all the data sequentially, or do you have to send the address for each? Send the address
no, you
for
just send
the pixel you want to control.
It's just like in Neopixel. You have to send all of the data at once.
Okay, can you drive it from either end or even in the middle?
Yeah, you can drive from either end. That's a good point. Yeah,
okay.
you can.
Can you cut the strand? If so, how do you set the address for a new strand? Do you have to know?
Cannot.
Okay.
It's fixed.
Okay.
So if you cut it, like I cut that piece and I showed like it wasn't, even though two pieces were in parallel, they still thought that they were at the end because again it's in parallel. It doesn't know what, it has the fixed address built in. It doesn't have its location based on where it is on the strand the way normal Neopixels are.
Okay, for the GPS thing, is the bits that have changed things that were like patent or something, or was it just...
No, I think it's just...
I don't think these have been around for a while.
It's not a patent thing. I think it's more... Because here's the truth of the matter. The Sierra Wireless, they don't make the GPS chip itself. The GPS chip is an MTK 5562 or something. It's by MediaTek. MediaTek actually makes the GPS chip. Just like, our microchip, Atmel does not make an Arduino. They make the chip that's used in the Arduino, but they don't make the Arduino. And like, what an Arduino is all the other stuff that's made for it. So the module from Sierra, it's like the tin and the pinout and the passives inside, and there's, I'm sure, the antenna management circuit and the antenna on top, and all that, and a little bit of the firmware customization is MediaTek's, is Sierra's. But the overall firmware, the underlying firmware is absolutely written by MediaTek. MediaTek gave them an SDK, which I don't have an NDA for, so haven't seen it. And I'm sure it's under NDA. And he basically is like DIY GPS module. Here's like all the stuff you need, and then you can customize and tweak it. And so that's why I'm able to contact this new factory CD and say, hey, I want you to like tweak something. So some things on the GPS were tweaked by me originally. So like the way the fixed LED lights up is something that I customized. Like it's not like the way I had it working is not natural, but is the way I thought would be best for the community. And so it was a custom firmware. So I'm just gonna tell this factory, like, here's all the things I customized. I'm gonna find the email from like 2009 and just do what I did then. And it'll just take them like a week or two, and then hopefully they'll be able to make a matchy.
Okay.
Which is very rare, by the way. It's very rare that you can find a company that makes a module that's drop-in compatible.
Back to the LEDs. So you could chain devices through the strands. Output from number 1 is input to number 2 through the wire. Then number 2 takes the input.
No.
Stuff.
It's all in parallel.
And outputs to another strand, maybe.
No, it's completely in parallel. There's no chaining. There's no changing the address. Whatever it is, it is.
Okay.
Yeah, it's all on one strip. It's like I squared C. It's like, oh, what if I move like one I squared C to the top of the chain? Does that change the address? No, the address is fixed. Like if you have a bunch of I squared C devices, it doesn't matter where they are on your chain. Like if you have STEMMA QT boards, the order in which they're connected does not matter. The address is fixed.
Okay. All right. You want to do research?
Okay. Oh yeah. So let's go to. I will look at the lead into the great search. Right. I can't just jump right in.
Yeah.
Okay. So let's go to the overhead. So I did do like I started one. That's over at the computer. I started one design because I saw a bunch of people asking like, well, I have this like RP2040 and I really want to use it with Wi-Fi, and I know for a fact that the RP2040 works with Airlift because I wrote like one of the first demos I did was because it's a great demo because it tests like everything. Is you take the TFT, an Airlift board, and like an I2C sensor, and you show the data and get it and write to I/O and whatever. It's because it tests I2C, SPI, shared SPI, TFT, background redraws and all that good stuff. And so I've tested the Feather with the Airlift Feather Wing, and so I know that works. And so I thought I would make a Metro, like an Arduino Uno shaped board with a Pico and an ESP32. And then what's interesting is I was looking at this and I was like, oh man, those modules are so big. And then I remembered there's now the ESP32 Mini. So as long as the price is basically the same, I'm actually going to change this from like the really chunky. Hold on, let me keep forgetting I want to turn on T-Docu so I can show you. So this like really big module, I can shrink it to be like a much smaller module, which could be good because maybe I could like have the on-off switch over here, maybe the LEDs over here. But there's plenty of space for the RP2040. The RP2040, another thing that's great about it is it's got like tons and tons of pins. So it's definitely going to be able to, it's going to have plenty of pins for all of the Arduino, GPIO, and then the 2x3 header over here. And then Wi-Fi and SWD and I2C. So I think it'll be an easy route. There's just like a lot of passives and capacitors I gotta add in because they need a lot. But then as I was doing this, I was thinking about how Phil is always telling me to add more capacitance. That's
usually.
He's pretty much constantly always telling me like, hey, you need to add a capacitor. And I realized that the Metro is one of the few boards that we have that has an electrolytic capacitor. And I thought that would make for a great search topic. How to find electrolytic capacitors and when you need them.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search, brought to you by DigiKey and Adafruit. And this week's Great Search is?
Electrolytic capacitors. Everything you need to know that I can cover in about 10 minutes. Okay, so let's, over here I've got this design I'm working on, an EagleCAD. It's got a big chunky power supply, and it's got these two capacitors. Let me just zoom into the power supply so you can see where they live. So one of these capacitors is 47 microfarad, 25 volts, and it sits before the 5-volt regulator. There's a little bit of power protection circuitry, on-off switch, and here is the 24 microfarad input, and it's in parallel with a 0.1 microfarad. And then over here, there's actually another 10 microfarad over here to the right, but this is the output. It's at least 47 microfarad UCIC 47 microfarad plus, and because it's a 5-volt output, I need at least 6.3 volts of a voltage rating for the capacitor. And then I thought I'd show on the overhead real fast what these look like. Okay, so what is an electrolytic capacitor compared to your kind of standard issue ceramic capacitor? Because you're going to see both in many designs. So this is an electrolytic capacitor. It's a metallic metal tin. There's a marking showing which one's the negative side. If you're using through-hole electronics, they look like this. You know, they come in various sizes. This one's a 220 microfarad, and this is a 1 microfarad. So, you know, you're going to find them. It's usually 0.47. Yeah, I've never really seen anything below maybe 0.22, 0.47 microfarad, and they'll go up to like farad. You can get supercapacitors, so many thousands of microfarad, easily millifarad, up to like 1 farad if you get a super cap, very big. They're large. They don't come super small. I mean, these are fairly small electrolytic capacitors, but you know, a lot of them are going to be fairly chunky. They actually are wound pieces of foil inside that create the capacitance. And you know, if you compare this board, which has 2, to a board like this, which has none, right? This has no electrolytic capacitors at all. It has ceramic capacitors. So why do you want electrolytic on this? Well, first off, if you have the space, electrolytic capacitors, for cost per capacitance, you're going to get a much better deal. Like, you know, a 10 microfarad ceramic capacitor is going to cost you maybe 10 cents. For that same price, you can get something that is, 200 or 470 microfarads is electrolytic capacitor. So you're going to get much more capacitance. Second, if you do need a lot of capacitance for your circuit because you have a big power supply with a lot of, a lot of current draw and inconsistent current draw that you have to protect against, with ceramic capacitors, they don't, like, you can get 100 microfarad, but you don't really see them higher than that. Ceramics, you can see them as little as 1.2 picofarad, right? They'll get as small as possible in the picofarads, and up to, 10, 22, 47, and maybe 100 microfarad. You can get that high, but they start getting expensive, and they start not being as effective. Ceramic capacitors are highly affected by the DC voltage across them. They're very small. They're great at high frequency work in use cases because they have a low ESR. But when you have a big power supply, like on this board, where I'm going to be like drawing a ton of current, like up to an amp, and it's going to be driving servos and whatever, instead of having, 4 10 microfarad capacitors in a row, which I could have, instead I pick one large electrolytic. It's partially a cost thing, but also, this one is a 100 microfarad 6-volt capacitor. Again, to make that with ceramic capacitors, you either have to pay a lot more, or you end up having a lot of capacitors in a row, and these work wonderfully, and they're durable, and I like them. So, they don't replace ceramics. Electrolytics have a big place. If you're making very petite electronics, chances are you're not going to use electrolytic capacitors. But when size isn't an issue and you want to reduce costs, you're going to definitely go for electrolytics. So that's your 2-minute briefer of when you want them. Okay, so let's go to digikey.com, and we can, that's the capacitor. So again, there's more than 3 basic basic capacitors, but there's kind of basically 3. There's the ceramic, I mentioned, really good for high frequency. 10 microfarad-ish or less is what they are best at. Electrolytic, big, inexpensive bulk capacitance. Pair them with a ceramic, and you got the high frequency and the low frequency matched up. And there's tantalum or tantalum. A lot of folks will use tantalum because they're very nice in between. You can get very high capacitance, 220, 470 microfarads easily, high voltage rating. However, I found that they're more delicate. It's a lot easier to pop them. Ceramics are nonpolar. Electrolytics are polar, but they can kind of put up with it a little bit. Tantalums will just pop instantly the moment you abuse them. So watch out for that. And second, you want to make sure that your tantalum is being ethically sourced. If you're getting electrolytics or ceramics, you don't have to worry about that as much. So let's look for electrolytic capacitor. And there's going to be thousands. That's one of the nice things about electrolytics is they're so generic. You're going to be able to have tons of options. Like you never have to really worry about am I going to be able to find an electrolytic capacitor in stock? Don't worry, you will. It's like resistors. These are plentifully made. So that said, here you go. There's you can see there's two areas. There's tantalum and there's aluminum electrolytic, and we're going to go to aluminum electrolytic. No, there's about 100,000 of each. Okay, so under electrolytic capacitors, again, there are a lot of options, and you're going to want to very quickly narrow down, because even when you get to one of the most, you really narrow down, you're still going to have 100 options. So just be aware of that. It's not going to be like some searches where we're like, let's craft the perfect search, and then one item pops out. With capacitors, you're going to have a lot of options no matter what. So look at what's in stock, what's available, what you care about, but you'll have a lot of options available. So let's first look for only active. We don't always see this, but on capacitance, because oftentimes folks are looking for a range of capacitance, instead of shift clicking, you can have a minimum and a max. So let's say I want 47 to 100 microfarads, and I believe, so that automatically updated to about 11,000 options. That's kind of nice. Tolerance. It depends on how much you care about this. For some audio use cases, you might want a tighter tolerance. For bulk capacitance for a power supply, what's nice is that the tolerance basically is just how much they bin them, right? So you'll rarely get less than 10 or 20% negative, but positive it could be over, right? Which is something you have to think about. Usually when you have a bulk capacitor for your power supply, you don't care if it's twice as much. You're bonus, free. It's kind of when you open up your drink and it's filled up all the way to the top, and you're nice. It's an extra sip in it. You don't care as long as it isn't halfway full. Same thing with capacitors. Electrolytic especially, they mass make these, and they're as long as it's not less than 47 microfarads, it goes in the bin. Okay, so there's also one thing to watch for is there's through hole or plug type, and there's surface mount. So chassis mount and surface mount. So through hole, just to show you real fast, is your standard. You can get axial this way. These are kind of nice. They sit nice and flat on the PCB. And then this is, of course, your common everyday electrolytic capacitor. Through-hole electrolytic capacitors are great. I have a bin of them. I do recommend picking up a bunch if you don't already have some, because they're always useful for stabilizing power supplies and Neopixel LEDs. You add a big capacitor, nicely smooths out the power supply for you. That said, I'm going to undo the mounting type because I actually want surface mount. Sorry. Okay. So surface mount, and then now it's okay, there's a couple different, there's a lot of different settings that you might not care about, but the one thing you'll definitely want to look at is the voltage rating. Electrolytic capacitors work best when you give them at least 20-25% of headroom above the expected voltage you're using. So if you have a 5-volt power supply, you'll want it to be rated for 6.3 volts. And you'll notice like the voltage ratings are like, they're like, oh, there are more than common rail voltages. So if you have a 3.3 volt rail, pick 4 volts. 5 volt rail, 6.3 volts. 7 or 8 volts, 10. 16 is 12 and above. 20, 25. You basically just pick the next one up and give yourself a little headroom. For this power supply, 12 volts in is the maximum DC input, so let's pick 6 volt rating. You can always go higher, right? So if you can't find the capacitor you want and the size you want at 16 volts, just bump it up to, you can always get 20, 25. But I'm not worried about getting the right capacitor, so I'm just going to pick 16 volts. Okay, so next up, you see the tolerance kind of now. We only have 2 options for tolerance. That's great. Polarizations, bipolar or polar. Bipolar means that it can be, current can go either way. The voltage, the bias voltage across it can be either way. Current, of course, can go back and forth depending, as long as for unipolar, as long as ground is lower than the power rail, the positive rail. Bipolar, it doesn't matter. They're actually designed so they can go either way. Those tend to be used for audio. I don't really see them anywhere else, to be honest, but for audio DC blocking capacitors. That said, you will pay more for them, and they're pretty rare, so I'm just going to get rid of that option. Okay, and then size and dimensions. So all capacitors come in very standardized sizes, which is really great. So let's go to the overhead real fast, and I can measure this. It's tool use. So for this capacitor, I measure it. This is 5.2-ish millimeters. This one is also 5.2. But if you look, they're a little bit smaller than the outline. When you're buying electrolytic caps, you'll pay less if they're bigger. You'll pay less if they're wider. You'll pay less if the voltage is lower, and you'll pay less for a lower capacitance. So more capacitance, you'll pay more. Higher voltage rating, you'll pay more. Smaller size, you'll pay more. So all things considered, if you're concerned about cost, you might as well just go with the biggest one you can fit on your PCB. Okay, so we can go back to the computer. So I'm going to pick 6.3 millimeters, which is the size. Seated height, this may matter to you. In my case, I don't really care too much. The seated height is not that important, but you'll see the majority of them they're not all the same. The diameter is more standardized than the height. And then, now you still have quite a couple hundred of them. So, what are you going to use to differentiate? Well, you're going to pay more for lower ripple current. So the ripple current is basically tells you how good is it at keeping them from being variations in current and voltage. So you'll get lower noise, basically. There's a shortcut. Impedance, ditto. High impedance, cheaper. So here, 4 ohms. Lower impedance, you're going to get less ripple. Ceramic capacitors, in exchange, as a comparison, have much, much lower impedance. I think this is the same as... Oh, no, sorry, it's not the same as the ESR. Sorry, I'm mistaken. Although I don't know what the impedance is compared to the ESR. So the ESR, the equivalent series resistance, the lower it is, the less ripple, and usually the more stable your power supply is. Ceramic capacitors have much, much lower ESR. I have seen some power supply chips that require high ESR for stability, for their feedback loop. I only saw it once, but it actually made a difference. The power supply chip said, do not use only ceramic capacitors on the output. You have to have at least one electrolytic capacitor. So you'll pay more for lower ESR again. They're almost all rated at about 120 hertz, but I guess some are rated at 100 kilohertz. For me, it doesn't matter so much. There's also lifetime temperature. Again, this is whether you want something high reliability at high temperature. Electrolytics, as people who do power supply work know, they can die if they are used for a very, very long time, or they're poorly made, or it's very hot. So all these things are reliability. I'm just going to go for general purpose. And then I'm actually going to like check just for the ones in stock. So that's 59. And then there's still a lot of options. And then this is where I actually like do my little shortcut. I just filter by hold on. Sorry, yeah. I filter going down by quantity, because at this point I'm like, there's too many options. I don't know what to pick. You can do it by price, but it's tough because again, there's so many variables of what you're paying for. Comparatively for the lowest like current ripple, the lowest ESR, lowest size. So I kind of just go with like whatever's popular. And so in the end, I actually thought, okay, this 47 microfarad, 16 volt, plus or minus 20% looked pretty good. The lifetime temperature, I don't really care. It's polar, I know that. The ripple current was not too high, 58 milliamps. And the ESR is, hold on. Oh, the ESR is not rated here. You have to look at the data sheet. So, hold on. I will say checking out the data sheet is going to be very helpful. First off, because they have like all the dimensional data, and they'll also tell you all of the different, if you like the capacitor you have, but you want to get one with like smaller diameter, or you want to get one with a little bit more capacitance or better tolerance, you can use the numbering system to figure out like how to like calculate what the part number would be that you want. Let me see. Okay, so it's got the ripple current is here. Let's see if they have the ESR. I think they don't. I think they're just general purpose, and they're like, we don't really rate them. They just tell you like, it's probably like, an ohm maybe or something. Of course, you can also measure it when you get the capacitor itself, but it sounds like it's not guaranteed. Which is interesting. All right, but for general purpose, this is good enough for me. I'm using this with a 7805. The 7805 is like not very picky about the capacitance, and then I add some ceramics as well. So I ended up purchasing this one, and I think it's gonna be just fine. I like Nichicon as a supplier. I've never had any issues with them. I'll say that there's a lot of suppliers. I think they're all going to be equally as good, but I've had very good luck with Nichicon the entire time I've made electronics, and so I kind of tend to use those or Panasonics. Again, electrolytic capacitors are very jelly bean. Doesn't really matter, but if I have two, and one of them is Panasonic or Nichicon, and one is some other brand I haven't heard of, those are the two I'm going to go for. So those are my electrolytic capacitor tips in the Great Search.
That's a great search for this week.
Where in the world is that part I need? The Great Search with DigiKey.
All right.
Okay.
One follow-up question for the GPS revision. Will you be able to use the same commands? So are the new modules compatible enough to flash different firmware to accept the old commands?
I don't know, and I cannot say that you should do that. First off, I don't know if you'd brick it, and second, I'd rather just get equivalent firmware from the new factory, because I'm assuming that there are some other differences internally. Like the module doesn't look 100% the same. There could be like pin variations or something. I don't know if you can just flash the old firmware on. I'd prefer just get it like with the firmware good to go out of the box.
Okay. And with that is our Desk of LADYADA for today.
Okay. Thanks,
All right.
everybody.
We will see everybody next week. LADYADA o'clock-ish. See everybody during the week during the shows. Stay safe. Keep going, because it's the only thing we can do at this point.
Keep your LEDs blinking.